Hello everyone, I'm Aaron, an Android developer from Line Taiwan Android team. Today I'm going to talk about Flutter fast development practice in Line shopping app. This is this session's agenda. I will introduce the Line shopping app and then talk about the background of why we need fast development and our solution. And I will share what we used in this app and the challenges we faced. In the end, I will wrap this session up and give you some summary. Let's start with Line Shopping App overview. The Line Shopping app provides customers with one-stop shopping experience. No matter you are looking for product or looking for food, even looking to travel, you can find what you want in this app. The shopping app also provides smart price comparison. You can look for which shop has the best price. You can also look for when a product has the best price. More than that, you can get a Line point reward after purchase and redeem for your next purchase. Next, I will talk about the background of why we need fast development and our solution. The background is we only have few Android and iOS developers, and we need to develop applications for both Android and iOS applications in a short period of time. In such a condition of limited resources and a tight schedule, we need to find a solution to complete this mission. And our solution is Flutter. Flutter is a cross-platform UI toolkit made by Google and written in Dart language. Flutter enables you to build applications for both Android and iOS platform from a single code base. With Flutter, you can maximize your resources and speed up the development cycle time. Besides the cross-platform advantage, Flutter also provides some benefits. First, fast development. Flutter can apply your code changes in milliseconds without losing state with stable hard reload, which will incredibly reduce your development cycle time. Second, expressive and flexible UI. Flutter provides built-in material and Cupertino design widgets. It is easy to build native-style applications. Besides, these widgets are designed for the convenience of use. Third, the native performance. Flutter provides 60 FPS native performance that make your Flutter app run as native performance. Next, I will share what will be used in this app. I will share the dependency injection, the state management, and the architecture approaches applied in this app. Let's start with the dependency injection. The plugin we used to inject dependency is Provider. Provider is a wrapper around inherited widget to make them easier to use and more reusable. And here is an example how to inject a dependency using Provider plugin. And here's a widget tree. We have root widget, intermediate widget, and the leaf widget. Suppose we want to provide dependency in the root widget. We can use the Provider plugin to provide a dependency. And then no matter the intermediate widget or the leaf widget can access the dependency provided by the root widget directly. Next, the state management. The state management approach we used is the BLOC, business logic component. The BLOC is conceived by Google's engineer. The concept of a BLOC is to move business logic to a block, so like the business logic can be removed from the presentation layer as much as possible. And here is how a block works. A widget sends an event to a block through the string sync. Then the block processes the given event, then emits multiple states through string for the widgets to update. An event can emit more than one state during the block process. Fortunately, there is already a plugin called BLOC that is made to easily implement a block pattern so that we don't need to deal with the string by ourselves. And here is an example: search products. The product search result page will send a search product event to a search product block. Then the block will process the given event, then emit a search product state for the product search result page to update its widgets accordingly. And we need to define the input events and output states for the product search block. For event, we define a search product event. It takes in a query string from the user. For state, we define a search product state, but actually it has 3 states: the loading state, success state, and the error state. And the detailed implementation of a product search block, it extends a class called BLOC, which is from the BLOC plugin. And the constructor takes in a search product use case, and it emits a loading state as initial state. And then we need to override map event to state method. First, we emit a loading state when receiving a search product event. Then we use a search product use case with a given query string to search for products, and then return a product list. Then we convert the product to product view model, and we emit a success state with the converted product view model list. If there is any problem occurs during the process, we emit a state with the thrown exception. In the conversion method, it formats the product price from an integer to a formatted string. The product view model here means the data model for view to present. The view model contains mostly string and the flag that the view used to display the data. And suppose the product search block has been provided by an ancestor widget, so we can access it in the product search result page directory. Here we add a search product event to a product search block, and then we use a block builder to listen to the state changes. If the state has a loading, we show a circular progress indicator. If the state has an error, we show an error message. If the state has success, we show the product search result in a list view. Next is the architecture. The architecture we used is clean architecture. The clean architecture is proposed by Uncle Bob. It is an attempt to integrate all similar architectures into a single actionable idea. The objective is to achieve the separation of concerns by dividing software into layers. The clean architecture has an overriding rule called the dependency rule. The rule is source code dependencies must point only inward toward higher level policy. Nothing in an inner circle can know anything at all about something in an outer circle. And here is a flow of control in the shopping app. Let's take the search product use case mentioned earlier as an example. Users interact with the shopping app with the product search result page and send the search event to the product search block. Then the product search block will ask the search product use case to return a product list. Then the search product use case will use the product search repository to get the product domain model list. And it means the product search repository needs to know where the data source is from. However, it violates the dependency rule. To conform to the dependency rule, we need to follow the dependency inversion principle. We declare the product search repository as an interface, and we only need to define what we want. And in the implementation of a repository, the repository can access data from local database or from the network API. For the same reason, we define the product search DAO as the interface for local database, and then we define the product search API service as an interface for the network API. And in the detailed implementation of Product Search DAO is using the SQLite database. And in the detailed implementation of Product Search API service is using GraphQL. Then the flow of control goes back to the Product Search repository. Then the repository will convert the return data model into a product domain model list, then return to a search product use case. Then the use case will manipulate the returned product domain model list. And for example, we will add the filter logic, then return the filter product list to a product search block. Then the block will convert the product domain model into a product view model list, then emit a success state for the product search result page to update its widgets accordingly. During the development period, we also faced some challenges. I categorize the challenges into 3 kinds of issues: the development issues, the plugin issues, and the framework engine issues. Let's start with the development issues. The issue I mentioned here is scoring performance improvement in staggered review. As you can see on the phone screen, we want to show the product result in a grid view with staggered effects. So we use a plugin called Flutter staggered grid view. However, there is one problem. The staggered tile with fit options will calculate its height based on its content. If you have dynamic content, it will affect the performance while scoring. For each content, the height could be dynamic. However, for the same content, the height should be the same. To solve this problem, our solution is to catch each shown content. So once the same content is scrolled to shown again, we use the staggered tile with extend options and give it the cached height to solve this issue. And the plugin issue here I mentioned is the unsupported HTTP cookie same site in-app web view. In the shopping app, we support open partners website in the shopping app. So we use a plugin called in-app web view to deal with that for us. However, there's one problem. The in-app web view doesn't support the cookie same site at that time. So what should we do? We have 3 options. First, fire an issue and hope it can be merged as soon as possible. Second, if we already know how to fix it, we can fire a pull request and hope it can be merged immediately. Lastly, clone its repo and customize it on our own. And at that time, the in-app view rarely updates, so the option 1 and option 2 doesn't work for us. We don't have no choice but to choose the last option. We clone its repo and customize it on our own. The next is the framework engine issue. The issue I mentioned here is keyboard language switch manual function in Android web view. In the shopping app, user can search for products in the partner's website in the in-app web view. However, there's one problem. User cannot switch their keyboard language to Chinese, and that's a very serious problem because it means user cannot proceed with the shopping flow. And this issue only happens to Android platform because the integration of the native view and the Flutter widgets is unstable on Android. And then it causes lots of problems, and then this issue is just one of them. To solve these issues, the Flutter team came up a solution called hybrid composition. The hybrid composition refers to the ability of composing native views alongside Flutter widgets. It is released in Flutter 1.20.0 and requires API level 19 and above. And that's a great news for us because it means we can use it to solve the keyboard problem. However, the shopping app is prone to crash while switching between foreground and background after using hybrid composition. Since it's the Flutter engine issues, so even though we can clone its repo and customize on our own, we can only build a debug engine. So we fire an issue to the Flutter repo and provide a simple project and tell them how to reproduce these issues. And after a few weeks later, this issue is fixed and released to the beta channel. According to the Flutter channel documentation, the beta channel is fine to use. If there is anything you want is available on the beta channel. So eventually, we use the hybrid composition and switch the channel to beta channel to solve the keyboard problem. And I will wrap this session up and give you a summary. In the beginning, I walk you through the live shopping app overview. The live shopping app provides customers with one-stop shopping experience and a smart price comparison, and also live points reward. And I also talk about the background of why we need fast development and our solution. Our background is we have limited resources and tight schedule, and our solution is to choose Flutter. And I also show some benefits. The Flutter has the stable heart rate load, the built-in Cupertino and the material design widgets, and the 60 FPS native performance. And I will also share what we used in this app. Regarding dependency injection, the plugin we used is a provider. And the state management, we use the BLOC. And the architecture, we use the clean architecture. And as for the challenges, I categorize it into 3 kinds of issues: the development issues, plugin issues, and the framework engine issues. And the summary is, Flutter is an efficient cross-platform UI toolkit. And the integration of native views and the Flutter widgets is still unstable on Android. And also pay attention to Flutter plugin and the framework engine issues. And that's it for this session. Thank you for joining.